Hi, this is part two of our video on how to make a karyogram. So in this video, we'll be um, learning um, how to pair our chromosomes into a homologous chromosomes and how to arrange them in a decreasing order from longer chromosome to shorter chromosome. So we will use our previous data before the Panax ginseng chromosomes. We enhanced, we overlay, we assign colors. But in this case, I added the two ginseng um, chromosome specific or ginseng genome specific probes to add more like more signals or fish signals. So just open here. So this one is we used this before, or we can just in my case I want just to yeah, we can just open and then where is the PSD file. So we should have we'll use the PSD file. Yeah, this is the PSD file to edit this the previous karyogram of ginseng we have. So here you can see that we added different colors like the yellow and the purple. So these are just the additional ginseng specific probes named as PGPR1 and 3. So from here, we will we will pair homologous chromosomes. First way of pairing is the chromosome signals like the 5s, 45, and telomere. So they are always they should be paired. And then the next one is you have to pair them according to their length, the size. You can also pair them according to the chromosome type, the location of the centromere, and the DAPI type, the DAPI band also. So that will be methods on how to pair our chromosome. First, the fish signals, the DAPI bands, the chromosome length, and the chromosome type or the centromere position. So how to um, prepare a karyogram for this? So first, we have to create a path. Create a path or maybe, no, not the path. We have to put numbers, assign numbers to this one. Which one is number one and which one is number two? Since this ginseng chromosome has 48 chromosomes, so we have to assign chromosome 1 to chromosome 48. So let's click this tool type and then this actually horizontal type tool and then assign here number 1. That's too big. So we can reduce the font size to 18 or maybe 14. And then maybe, oh, the color is white. It's okay. So just move the color here. So just assign each chromosome a number. So this is chromosome 1, 2, 3, 4, 5, 6. So in this way, you will not forget which is chromosome 1. Okay. So later on, when we arrange them, chromosome 1 should always be there. So we will know that this is chromosome 1. So when we go back to our raw data, I want to confirm the signal of chromosome 1. So you will know that this is chromosome 1 because I have number here, chromosome 1. Okay, it's chromosome 1. And I already added number actually to here. So I will just put the numbers. So here in this folder, I just create a number here from 1 to 48. So I will just use this one. Oh no. Delete this and use the folder number. And you cannot see this because they are really in the bottom layer. So I want to move this on the upper layer. So you can see that these are now my assigned number to each chromosome. So this is permanent. So 1, this is chromosome 1, 2, 3, 4, 5, until chromosome 48. Okay, but if you're sometimes lazy to put number here individually, because you have to add this individually. You have to click this and then press 1 and then click this arrow bar, arrow icon, and then click this one again, and then 2. So you have to repeat that one 48 times, and it's somehow time consuming. So you can also use this part here, right click, and then you have here, oh no, there's no, only note tool, there's no number. If you're maybe in your Photoshop, you have here the numbering, so you can use that one. So anyway, never mind with that one. So just have this, it's more reliable. Okay, so next is we will make a path. So in your let me hide this one. In your panel here, you have layer, panel for layers, channels, and for path. So here, your channels, I already have these, the red, blue, and green. So just never mind of that one. And then for paths, I already created here paths, but I will teach you how to create path. Okay, so just click the path here. Although I have already path for chromosome 1 to chromosome 48. So let's try on how to make path. Let me hide. Can I hide? Oh yeah, I can hide. Now I know. Okay, how to make a path. So to make a path, you have to draw using the lasso tool. Draw and try to capture the chromosome. Okay, so that's just try to capture. So don't really make a, like, you have to just do like this, because that would cover all this area here. So when you move a bigger part. So you remove a bigger, this entire region here, you cut with your lasso tool. So just create a, like, just capture the chromosomes you want. But never mind when sometimes you included a little bit of the portion of this chromosome here. You just never mind, just focus on this chromosome. So if this chromosome somehow overlay with the other chromosome arm of this chromosome, then just never mind, as long as you capture the entire chromosome of chromosome 1. And if you have that, just right click and then work path, make work path. So click that one, and this will appear. Just click OK. When you click OK, you can see that one here, work path. And then you can double click this one. No, what is it? Double click, and this one will appear. And then you can name this as maybe your chromosome 1. So you can name in what you want. So that's chromosome 1. And then you have to make another work path for chromosome 2. Here, chromosome 2. That's not good. Chromosome 2, just capture the chromosome. Never mind if you included some other area, later on you can just delete them. Right click and then make work path. And you can see it here. Double click and then it's your chromosome 2. Okay, that's it. And if you have something like overlapping chromosome, let's try to have some overlapping chromosome. Do I have? maybe this one here for 45 days. So you can just copy the chromosome here and include the signal. Never mind if you copy some part of the chromosome here, because later on you can just delete that part. Right click and then make work path. Okay, and this is your C40 chromosome 47. So you have to repeat this one 48 times. 48 times until you make work path from chromosome 1 to chromosome 48. So in my case, I already have the chromosome, a work path for the 48 chromosome. So I will just remove this one. Because I just show you the way on how to make a work path. So I will delete this and this one. So assuming we already finished making work path from chromosome 1 to 48, now we have to transfer them into another file. So how to transfer? Create another new file. So new, and then you have this. So maybe we can change 50, 30, maybe it's fine. And then you should have the background color or any color. I want background color because I want the dark background here. If you look transparent, that will just be plain white and it could be ugly. And okay. So now you have this new file here. So in your new file, you can transfer these chromosomes all together there. So how to transfer? So easy. Click the chromosome 1 in your path here. And be sure to click the signals you want to transfer first. So in my case, I want to start from DAPI. So for my DAPI, row DAPI, I want to, let me check if my row DAPI. See, this is a row DAPI here, right? I will hide this. This is the row DAPI. Oh, the row DAPI is not accurate. No. Okay, so this is our, I will copy the DAPI. Maybe it's from here. Here the DAPI. This is my DAPI signal. So I will copy the DAPI. Yeah, this is my DAPI. But why my DAPI is not? So you can click your DAPI. Or you can use the row DAPI. The row DAPI should be used. But seems like the row DAPI is not. So I want to. Okay. So I want them to fit in chromosome 1. So this is DAPI. So click the DAPI. This is the image you want to transfer. And then path. And this is chromosome 1. This is chromosome 1. So I will transfer the DAPI chromosome 1 to the new file. And you have already here the contour, what's that, the lasso assigned to chromosome 1. And I want to activate this one by clicking this broken line here. So click this and you can transfer now this chromosome. See, it's, and then drag this to the new file and then release. So you have here now the chromosome 1. And next is chromosome 2. So it will just automatically transfer to chromosome 2 and then drag again here. So actually it only provide you a copy. Even though you remove the chromosome 1 here, it's still here. You just remove the copy here. You will just automatically copy. And then chromosome 3, and then in the broken line here, and then drag. So you have to repeat this 48 times until you finish your you finish the, if you can see here, Yeah, so just something like that. So this is only, we will only stop until chromosome 4, until chromosome 4. Then after that, assuming that we already finished the transferring of chromosome 1 to chromosome 48 here, we will transfer again the another signal. So I will start with the merge signal here, 5s. So for 5s, I will start from chromosome 1. Okay, chromosome 1, then broken line, and then drag here. This is my chromosome 1 for my 5s. Chromosome 2, three, here, and 4. Or maybe we will include the one with signals. So the one with signals is chromosome 8. So it's, no, it's 7 rather. So we include the one with chromosome, so we can use this. 7, and then we also have chromosome 17. 17? I'm sorry, 19. Why I cannot clearly see? Chromosome 19, and then the chromosome here 26, then chromosome 34, 34, chromosome 37, and then chromosome 39. So we have these 5s signals, and then maybe 5s signals. Maybe for DAPI, will also include this for DAPI. So we have all complete here. DAPI, it's 38. Oh, no, no, no. This one is 39. Next is 37. No, this is DAPI. I should put here DAPI. This is 34. 34, and this is, what is this, 26. Oh no, so when you got wrong moves, just control Z. Oh, that's wrong. Do not apply. And you have the chromosome 19. And the chromosome 8 or 7. Rather. Okay, so you have that. Next is the 5s and a 45s. So if you want to transfer to 45s, open this icon, click the 45s, and since you cannot see the 45s here, you hide the 5s because they are in the upper layer. So you have the 45s here in chromosome 45. So go to path, go to chromosome 45. Yes. And then you can drag this. And 47. So that is how you transfer here, 47. So assuming that we already transfer here the 5s, another the DAPI, the 5S, the 45S. Let's put name here so we will not be confused. So here this is DAPI. Change the color to white. Increase the font size, maybe that one. And then this is 5S. 5S RDA. And this is 45S. 45S RDA. And then the next one is the telomere. And then we will also include the merge. Okay. Now we have this, the 45S, the 5S here, telomere, and the merge. So you can just move it to here, right? Okay. And then, look at that. Maybe for 45S, let's include the signals from 5S. So we have, okay, let's include 1. Okay, 1, 2, 3, 4. Then the 5S, 7. I just want to capture the one with signals. That's why. But in your case, you should start from 1 to 48 accordingly. It should be consequence. 19. Here I just want to focus on the one with signals because later on we will use this to pair the homologous chromosomes. Because if you not use this, it's hard to use the DAPI only. 34. And then we have the 37. And 39. That's wrong moves. Okay, but here we do not have the signal, so we should add something here also, right? That's for the 45S. So that's chromosome 45 and 47 is 45S. So chromosome 45, I will copy this. Oh, no. Wrong. I will copy the 5S because I want the 5S. Because this is 45, there's 5S. And then the 47. 47. And also the DAPI. You should have DAPI. 45 and 47. 45 and 47. Now, this is the problem. If your chromosomes were not really aligned correctly, are not really overlapped. So you have cut chromosome, not exact chromosome. So, but for the sake of illustration, I will just use this to show you on how to transfer each chromosome DAPI to a merged color. So next is telomere. So in telomere, let's click the telomere here. is merged so I can see the signal clearly. So telomere, let's start with chromosome 1. This chromosome 1. No, should be only telomere. I only click telomere. Telomere. The telomere. So be careful when you click, be sure that you transfer the one which is the correct one, this telomere. Okay. 1, 2, 3, 4. 4. Then the with 5s, 7. And then 19. 19, and then next is 37. Here, 30, 26. And then next is 34. 34. Next is 37. 37. Next is 39. And then let's try also the chromosome with 45s, the chromosome 45, and chromosome 47. Okay, so that's for telomere. Next is for the merge. Merge. So let's click the merge here. You go to path, chromosome 1. So you have to repeat this 48 times in one signal. And since we have 1, 2, 3, 4, 5, so 48 times 5. That's how many times you have to repeat. Oh, where am I? Okay, so number chromosome 2, 3, 4. Next is 7. So if you have fewer chromosomes, then you have easier life. Here, a lot of chromosomes, so it's very time consuming and very hard. 26. So here I just selected the chromosomes with signals. But when you prepare the karyogram, you have to start from 1, the next 2 until you reach the last chromosomes. So you will have smooth copying or transferring of these chromosomes. So in my case, I just selected the one with significant signals. Oh, I did it correctly. Oh. 1, 2, 4, 4. Okay. Next is the with 45s signals. 45s chromosome, and then last, finally, 47. Okay. Now, assuming that we already completed the 48 chromosomes here from chromosome 1 to chromosome 48 until the merge signals from chromosome 1 to chromosome 48. Now, if you will just do like this, you wouldn't know what chromosome is this one. So it's very important that this chromosome should have number above here. That this would signify that this chromosome is 1, this chromosome is 2. So let's copy here the chromosome. Here, the chromosome number. These are the chromosome number. So in our case, I will just select this, or no, we just use chromosome 1 to 4. Chromosome 1 to 4, and then the 45S is 7. Not 5, 19. 26. 34. 37. 39, and then for the 45, we have 45 and 47. It includes 7. Yeah, includes 7. Here. So I want to transfer these, only these numbers to here. Okay. These are the only chromosome we used, right? So I will assign this chromosome 1 to here, 2. No. I'll make it zoom in. 3, 4, and have here 7, 9, 27. We still have 26, 26, 34. Oh, 39, 45, 47. Okay. Now, we are like mixed up, not organized. So I want to organize them, and I want to put them into one line and one row, one column. Okay. So how to do it? Important. So have the view here, click the view, and then click new guide, and this one will appear. So in a horizontal, I will position the line in chromosome. I will position, it's up to you, maybe 3. So here, my horizontal line would be in this area here. Okay, so that's my DAPI. I click to 3, so it should be 3, and maybe the next one will be 6. So I will position the next one in 6. So that's by 6. So we should have equal distance. Okay, 6 maybe here, 3, 6, 9. And then this one, the next is 12 and 15. Okay, so that's my position here. So I will move my DAPI to be aligned in this guide center, and my merge also to be centered on this position. So you have that. So you will only move the upper part and the lower part, and the rest will just follow. How? Just drag, highlight them all, and then after highlighting them, align them. You have this option bar here. Align them on the left edges. So click this, and they will move. So we have here equal or like, yeah, equal side. And then next is the distribution. They would be distributed equally. So in your option bar, you have this icon here. So they will be distributed in a vertical center. So click this, and here you go. They are aligned equally here. And we will do that in the other chromosome. So in your number here, you have number 1 to 47. So if you completed all the chromosomes, they should be from chromosome 1 to chromosome 48. In here, we only use chromosome 1 to 47. But I think it's better if we will first arrange the chromosome. So maybe this chromosome 1 to 48. Highlight them, all the chromosomes. Do not include the number, just the chromosome. Align them in the center. Yeah, like that. And you can drag down. So align them. And then distribute them equally. Okay, so we have to distribute them in the horizontal center. Click, and they have equal distribution. And you can have your number aligned to here. Your chromosome 1 and your chromosome number and chromosome 1 should be aligned the first. And then the last here should be aligned in center. So when you distribute this one equally, when you distribute this equally, and then your number also equally, highlight the number, only the number. Oh, I think I did not highlight the number. Highlight the number and then align them in the center. I did not include the others, so I have to do it again. Align them in the center. Okay, align, and then distribute them equally. So we have now distributed equally to the chromosome. And about this chromosome here, so these chromosomes, can align them too. Then align the center, and then you can distribute them too. Okay, and also here, align them in the center, and then distribute, and then this one will follow. So it will not take more of your time. So just align them together, move to the center, and distribute equally. And similar to here. Okay. So that's it. So easy. Align and then distribute. Now put them at the center, and this one too. Align, distribute, and then put on the center. So you have now your chromosome 1 aligned, 2 until 47. Here, already aligned. So that's how you do it by group, not individually, because it would take much of your time. Now, next, I want to teach you is you have to make your chromosomes really stand straight here, because this one is something like leaning on the other side, and some are lying like this. Not really. So you have to make them all stand straight. Okay. So how to do it? It's very important that you will record your movement, or every move you apply to this chromosome will be recorded. So you will just use that in the next chromosome, same chromosome, but with different fish signals. So how? Okay, use your action here. There is in your panel, there is an action button here. Click that one, and then you can make here new action or create new action. Click this, and this one will appear. So you can maybe name this as chromosome 1. record. So this is chromosome 1. So what will everything you did to the everything you will be doing to this chromosome will be recorded. So if I will move this, make it stand, be sure that your chromosome would stand like the short arm will be in this in the upper part and then the long arm in here. So if it seems like this is the short arm, right? Am I right? Am I wrong? Okay. So this is I think short arm and this is longer, right? This is just bigger, but something like that. And I want click enter. After you click enter, you stop. And then you can apply everything you did to here to all the chromosome 1. So no need for you to move this again, move like I have to move this similar. So because sometimes when you move, it's not always the same as the previous one, right? So just use the one you recorded. So click this and then play. So just click and play. Click and play. Click and play. Oh no, wrong. So easy. So you have to do that also in each chromosome. So in chromosome 2, I have to record again, name this as chromosome 2, and then I have to move. Okay, move. The short arm should be on the upper part, and then the long arm should be in the lower part. Then enter, stop. And apply that to the next chromosome. Just click and play. So click that chromosome and play. Okay. Now, the one you recorded here and applied to this chromosome 2, you cannot apply this to chromosome 3 because if you will apply this to chromosome 3, the movement would be similar to chromosome 2 only. So it will not bring you to the correct position. So see, it will just move like that, not according to the one you decide. So for chromosome 3, you have to record another one, name chromosome 3, and then you can move this. Stand straight, then enter, and then stop. And then click the rest chromosome 3, and then play, click and play, click and play, click and play. So you have to repeat that one to the entire chromosome. Okay, so that's how you record your action and apply to the rest of the chromosomes. Now, we completed already the karyogram. No, we completed already the all 48 chromosomes in all fish probes. So we have here the PGTR1, 3, 5, 55 telomere, the DAPI, and the. So I already prepared this one. So after a long hour, I already finished transferring all the fish signals and all the chromosomes. So I already applied all the actions, the alignment, and the distribution of the chromosomes, equal distribution of chromosomes. So this is from chromosome 1 to chromosome 48. Finally. So next move is we have to arrange them in a decreasing order from longer chromosome to shorter chromosome. So how to arrange them? So measure. You have to measure the chromosome with longer chromosome down to the shorter chromosome. So if you need the data, you need the value, the number, then you have to use different app like the image J, so you can really take note there the uh, the exact measurement. So later on, I will also teach you how to use image J and to identify chromosome type. But for the sake of arranging this chromosome in order for this time, arranging this chromosome in a decreasing order, I will just teach you the shortcut. But this shortcut is a lazy shortcut. Okay, how? In my case, because I only after of the chromosome length, I'm not after of the chromosome type, so I will just measure them using this rectangle tool. So I will just make a rectangle tool from the short arm to the long arm. And then I will record here the height. So this is 75 pixels. So I will record this as 75 pixels here. So I will change it to 75. Okay, so I think it's better if I will put this on the upper part. So they will not merge with the other layer because I layered them already. So this PGTR1 layer, 3 telomere merge, and the chromosome spread. So I have this, and this one I will measure this from tip to tip, and this is 57. That's 57. And this one is 61. And is 66. So just measure each chromosome. Only the first layer chromosome, the 48 chromosome, do not include and measure the rest because they have same measurement. Just this first 48 chromosome. And this is 57. And next is this one, 54. Now, if you completed already doing similar pattern from chromosome 1 to 48, then you can arrange here. 75 is the longer, then followed by 66, and then 61, 57, and 54. And then later on, you can just click which is 75. So when you click 75 here, you will know that, oh, this chromosome is 75. So you can just delete that bar you used to measure, and then you can just drag all this chromosome. Oh, why it's not dragging? Yeah, you cannot drag this because your background here, your base is not locked. So they will move also. So better lock this. So when you drag, you can drag them. See? So we know that this chromosome is the longest chromosome based on our initial measurement here. So just drag this, and this is the longest chromosome, your chromosome 1. And then paired with the next longest chromosome, 66, or this is chromosome 66. So I will delete the bar I used, and then just drag this chromosome. So this is chromosome 2 with longest chromosome. Okay, so that's how how do I call that one? That's how I arrange the chromosome in decreasing order. But of course, that is not the final because your pairing should not be only in the chromosome length, but in the chromosome signals, the fish signals. You have to pair them in fish signals, not in chromosome length. The chromosome length is just secondary. But here, I just want to identify which one is longer chromosome because I want to use the longer chromosome as the chromosome 1. Okay. So that's it. Now, assuming that we already finished identifying all the chromosome length from longest chromosome to shortest chromosome, then we will start pairing them according to the fish signals. Okay, so now we already arranged or identified the longest chromosome and the shortest chromosome here. But as you can see, although these two were the longest chromosomes, but they are not really paired because this chromosome contains 5S rDNA and the other one do not contain the 5S rDNA, so they are not paired, although they are the longest chromosome. So we have to pair them according to the fish signals. So maybe this chromosome is paired to this chromosome, although this is quite shorter and this is quite longer. And this chromosome is paired to this chromosome. They have the same intensity, signal intensity. And for 45S, you can see that this chromosome is quite longer compared to this chromosome, but they are paired. Okay? So they are the paired chromosomes. So we have to pair them according to their signal pattern, and also similar with the other here. So I just included the PGTR1 and 3 because they are very informative and we can use them to pair chromosomes. Because if we will only use the 5S, 45S, you can only use this 1, 2, 3 pairs and 4 pairs. And the rest will just be like maybe the DAPI bands or just naturally the length. So if there's no signals, no DAPI band, then you can proceed to the length. But if there are signals and DAPI bands, use that as a way of pairing homologous chromosome. So next to this, we will pair them, arrange them by pair according to the length and according to the signal pattern. Okay. Okay, so here I paired them already. Okay, so I will not make you stress on how to pair. So this is the longest chromosome, the 27, and the pair is chromosome 1, this one. So although this chromosome is next to the longest chromosome, but it's not the next chromosome, it's not the paired to this because it doesn't, the first longest chromosome doesn't have signals. So I paired this one to this chromosome because it contains signals here. So yeah, and then I use this as second chromosome because I base the measurement on the average from this to here, the average chromosome. And the next chromosome, it's quite shorter, although the next pair is longer, but the next one is a little bit shorter. So the average drag it, and yeah. So you have to consider the average measurement. Okay. And if you notice here, I put here still the chromosome number, assigned chromosome number, because if I want to maybe clarify the signals, I will not be having a hard time on looking for which or where chromosome is this in the original spread. So if you go back to original spread here, I have numbers here. And these numbers are equivalent to these numbers here. For example, here our chromosome with the strong signal of 5S rDNA, that's 37 and 39. If you go back to here, the 37 and 39 contains the same signal. So if the question, or maybe this signal is not really signal, maybe it's just a noise, then we can go back to the original file, and then we can clearly, we can directly or easily identify the chromosome we're looking for. Okay, so that's how you pair the chromosome. And the next one, it's very important to use the guideline. Okay, so you can find that here, the guide. So how to use the guide? Just click the guide and then the position in horizontal or vertical position. So here I already put here the guide, and I will show you. Here is my guide. So in my guide, we have equal distribution in the horizontal and vertical line. And my chromosomes were aligned in this way. So I put this guideline in the middle and then a chromosome on each side. So they have equal and nice arrangement. Okay, so just like that one. And of course, you have to insert your your what's that your scale bar, and the chromosome number. So these are the chromosome number, chromosome 1 to chromosome 24, because they're already paired, homologous chromosome. So this is now the chromosome 1 according to pairing, homologous pairing. Oh, why I moved this? I moved this because I did not lock it. So I have to lock. So I will not move it. Okay. If you want to, because this one is too crowded, there's a lot of lines. So I want to hide the lines. So just Control H. Control H meaning hide. So that's it. So we're almost done. And I think, yeah, we're almost done. So we can transfer this, arrange this final karyogram to another file, or you can just actually delete this one because you already finished. This one you just use this to arrange, and you just use this to for what's that, for reference. But you have already, this is your final output. So this one you can just delete this, and then you can crop. You can just crop like that. And then, yeah, so that's your final output. So for the number, here you have the chromosome number. Do not delete this one because maybe you will need this later. You just make them align. And I think you have folder of this already. Where did I save it? Yeah, here in the folder. So just hide. Okay. And save. So to save, same. Just file, save as, and then you paste the. So I put here the 24 pairs of chromosome because it's final product already. So yeah. So save the paste the, and then also save the TIFF. So that's your final output. Now, if you want, you can also change the color of this one, of your 5S. So maybe your 5S, you want to change this also to red, you can change this to red. Okay. And then your 5S, you want to change it to green, then you can also change that to green. 1 to 5. And then the PGTR, you want to change this to yellow, then you can change that to yellow. So yellow is 60. And then PGTR3 is purple, you can change that to purple. That is 288. Oh, did I change? Nothing. It did not change. What happened? Change to 288. Purple. Yeah. And telomere is green, blue. Blue is what I put it. 228. Okay, so you have that. And chromosome number, no need for this. I just want to make emphasis that this is chromosome number. So this is your karyogram of ginseng. So the 48 chromosomes were already karyogrammed, and now you have your final 24 pairs of homologous chromosomes in ginseng. So that's it, and thank you for your time. Hopefully you learned something. Enjoy and God bless.